Now let's see about least recently used page replacement algorithm. In short, we can call it as LRU algorithm. Whenever CPU needs to execute a page, then it checks whether that page number is present in main memory or not. If the page is not present in the main memory, then it is called as page fault. So page fault indicates that the corresponding page number is not present in main memory. So whenever a page fault occurs, then operating system loads that page from hard disk to main memory, but assumes that main memory is completely full. Then we have to replace one of the page in the main memory with the new page from hard disk. So which page we have to replace? That should be decided based upon page replacement algorithm. Here we are using LRU algorithm. LRU means the page that is least recently used will be replaced. So let's take this example. So this is our reference string. So these are the page numbers which CPU is executing. Let us assume that the size of the main memory is 3 frames. So main memory totally stores 3 pages with the help of 3 frames. So first page 7. So 7 is not present in the main memory. So page fault. Next to 0. 0 is not present in the main memory. So page fault. Next to 1. 1 is not present in the main memory. So page fault. Next to 2. 2 is not present in the main memory. So page fault. But here the main memory is completely full. So which page we have to replace? Out of 701, 1 is the most recently used page, whereas 7 is the least recently used page. So 7 should be replaced here. So in place of 7 we will get 2. Next 0. Next remaining pages as it is. 0. 0 is already present in the main memory. So there is no page fault. So here we have a hit. So hit specifies that the corresponding page is present in the main memory. Next to 3. But here the 3 means it is not present in the main memory. So there is a page fault. But here the main memory is full. So which page we have to replace? Out of 201, 0 is the most recently used page, whereas 1 is the least recently used page. So 1 should be replaced here. So in place of 1 we will get 3. Next to remaining pages as it is. So 2, 0. Next to 0, already present in the main memory. So there is a hit. Next to 4, not present in the main memory. So out of 203, which is the least recently used page. So 0 is most recently used, whereas 2 is least recently used. So 2 should be replaced here. So in place of 2 we will get 4. Next remaining pages as it is. So here we have a page fault. Next to 2, not present in the main memory. So which page we have to replace? Out of 403, 4 is the most recently used page. Next we have 0. Next we have 3. So which is the least recently used page here? 3 is the least recently used page here. So in place of 3 we will get 2. Next remaining pages as it is. Okay. Next we have 3 here. So 3 is not present in the main memory. So there is a page fault. So which page we have to replace? 2 is the most recently used, whereas 0 is the least recently used page. So 0 should be replaced here. So in place of 0 we will get 3. Next remaining pages as it is. 0 not present in the main memory. So page fault. So which page we have to replace? Out of 432, 3 is the most recently used page, whereas 4 is the least recently used page. So 4 should be replaced here. So 032. Next 3 already present. So hit. 2 already present, hit. Next what about 1? 1 is not present in the main memory. So the least recently used page is 0. Why? Because here we have 2, here we have 0. So in place of 0 we will get 1. Next remaining pages as it is. 2. So here we have the page fault. Next to 2 already present. So hit 0. So which page we have to replace? 2, 1, 3. So 3 is the least recently used page. 3 should be replaced here. So remaining pages as it is. So page fault. 1 already present. Next to 7. What is the least recently used page? 2 here. So in place of 2 we will get 7. Next to 1, 0. 0 already present. So hit. 1 already present, hit. So the number of page faults are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of page faults are 12. Let us see the next example. Here also assumes that the size of the main memory is 3 frames. So the first page is 2. So 2 is not present in the main memory, so page fault. Next page 3, 3 is not present in the main memory, so page fault. Next one 2, so 2 is already available in the main memory, so there is no page fault. It is a hit. Next 1, so 1 is not present in the main memory, but we can accommodate one more page here. So 1, so this is a page fault. Next 5, 5 is not present in the main memory, but here the main memory is completely full. So which page we have to replace here? Out of 2, 3, 1, 1 is the most recently used page, whereas 3 is the least recently used page. So 3 should be replaced here. So in place of 3 we will get 5. So remaining pages as it is. Okay. So this is a page fault. Next to 2. So 2 is already available in the main memory. So hit. Next to 4. So 4. Here we have a page fault. Out of 2, 5, 1, the least recent used page is 1. Whereas the most recently used page is 2. So 1 should be replaced here. So in place of 1 we will get 4. Remaining pages as it is. 5 already present in the main memory. So there is a hit. 3 not present in the main memory. So there is a page fault. So which page we have to replace? 2, 5, 4. So 5, 4, 2. So 2 is the least recently used page. So in place of 2 we will get 3. So remaining pages as it is. 2 not present in the main memory. So there is a page fault. So 3, 5, 4. 3, 5, 4. So 3, 5, 4. So 4 is the least recently used page. So 4 should be replaced here. Next pages 3, 5 as it is. 5 already present in the main memory. So hit. 2 already present in the main memory. So hit. So here the number of page faults are 1, 2, 3, 4, 5, 6, 7. So totally there are 7 page faults are there. So this is about least recently used page replacement algorithm.